we continue to the last part of subtopic 7.2, chemical properties of haloalkanes. At the end of this subtopic, students should be able to explain elimination reaction of haloalkanes, explain the use of haloalkanes in the synthesis of Grignard reagent, determine the structural formulas of alkanes, alcohols, and carboxylic acid prepared using Grignard reagents. Elimination reaction of haloalkane is same with the dehydrohalogenation of haloalkanes learned in chapter hydrocarbons for subtopic alkenes. Alkyl halide in the presence of potassium hydroxide in ethanol and under reflux produce alkene compound after elimination of HX. Look at this example, dehydrohalogenation of 1-chloropropane. 1-chloropropane in the presence of potassium hydroxide in ethanol under reflux eliminate HCl to produce propene and release HCl. Haloalkanes are used in the preparation of organometallic compound Grignard reagent. The symbol is RMgX, R is alkyl group, or ARMgX, AR is aryl group. Grignard reagents are generally prepared by the reaction of an alkyl halide with magnesium in dry ether solvent. It is general equation for the reaction between alkyl halide with magnesium in the presence of dry ether to produce RMgX, and the second general equation is the formation of ARMgX. Grignard reagent behave as carbon ion. Carbon ion is ion containing carbon atom with unshared pair of electrons and bear a negatively charged. Grignard reagents are used to prepare alkane, different classes of alcohol, and carboxylic acid. In the preparation of alkene, Grignard reagent undergoes hydrolysis with H3O+ to produce alkane. Grignard reagent react with methanol followed by hydrolysis with H3O+ to produce primary alcohol. Grignard reagent react with any aldehyde except methanol followed by hydrolysis to produce the secondary alcohol. Grignard reagent react with ketone followed by hydrolysis to produce tertiary alcohol. And Grignard reagent react with carbon dioxide CO2 followed by hydrolysis to produce carboxylic acid. I will explain about all of these chemical equations in detail for the next slide. In the preparation of alkene, Grignard reagent will undergo hydrolysis with H3O+. Carbon that bonded with magnesium is partially negative and magnesium is partially positive because that carbon is more electronegative than magnesium. When this Grignard reagent undergoes hydrolysis, carbon-magnesium bond break and MgBr will be substituted by H+. Finally, it produces an alkene compound and it releases MgOH-Br. Same for the second equation, Grignard reagent undergoes hydrolysis with H3O+. CH2MgCl will change to CH3 after H+ substitute MgCl. Alkane is formed. In the preparation of alcohol, carbonyl compounds react with Grignard reagent to produce the intermediate product. Carbon-carbonyl is partially positive and oxygen is partially negative because oxygen is more electronegative than carbon. Carbon in R1 is partially negative and magnesium is partially positive because carbon in R1 is more electronegative than magnesium. R1 attack carbon-carbonyl, a new bond formed between R1 and carbon-carbonyl. At the same time, pi bond in C double bond O break. Both of the electron will be transferred to oxygen to make oxygen has -1 charge. Oxygen with negative charge attack magnesium and a new bond formed between oxygen and magnesium to produce OMgX. Reaction followed by hydrolysis with H3O+ to produce an alcohol. H+ substitute MgX, therefore OMgX change to OH. It is the example for the formation of primary alcohol. Alkyl halide react with magnesium in dry ether to produce a Grignard reagent. Grignard reagent react with methanol and aldehyde with one carbon atom. Carbon partially negative from Grignard reagent form a new bond with carbon-carbonyl from methanol. C double bond O change to C single bond O after the pi bond in C double bond O break. O with negative charge will attack MgCl and form OMgCl. Reaction followed by hydrolysis with H3O+ to produce primary alcohol and release MgOHCl. H+ substitute MgCl, therefore OMgCl change to OH after hydrolysis. Second example also show the formation of primary alcohol but without draw the intermediate product. It is the example for the formation of secondary alcohol. Grignard reagent react with aldehyde except methanol. Carbon partially negative from Grignard reagent will form a new bond with carbon-carbonyl from aldehyde. C double bond O change to C single bond O after the pi bond break. O with negatively charged attack MgCl to produce OMgCl. The reaction followed by hydrolysis. H+ substitute MgCl, therefore OMgCl change to OH to produce secondary alcohol. Second example show the other way to write the chemical equation for the reaction between Grignard reagent and aldehyde without draw the intermediate product. Now the example for the formation of tertiary alcohol. Grignard reagent react with any ketone to produce the intermediate product. Carbon partially negative from the Grignard reagent will form a new bond with carbon-carbonyl from ketone. C double bond O change to C single bond O after the pi bond break. O with negative charge attack MgCl to produce OMgCl. The reaction followed by hydrolysis. OMgCl change to OH after H+ substitute MgCl. The product form is tertiary alcohol. Second example show the formation of tertiary alcohol without draw the formation of Grignard reagent. It is the other way for you to write the chemical equation. Preparation of carboxylic acid involves the reaction between Grignard reagent and carbon dioxide CO2. Label the partially positive and partially negative part in both reactants. Carbon that bonded with magnesium is partially negative and magnesium is partially positive because carbon is more electronegative than magnesium. Carbon in carbon dioxide is partially positive and oxygen is partially negative. Carbon partially negative from Grignard reagent attack carbon in carbon dioxide. A new bond formed between carbon partially negative in Grignard reagent with carbon from carbon dioxide. One of the C double bond O in carbon dioxide remain. One more C double bond O change to C single bond O after the pi bond break. Both of the electron from the pi bond will be transferred to oxygen. Oxygen with negative charge attack MgX to produce OMgX. The reaction followed by hydrolysis with H3O+. OMgX change to OH after H plus substitute MgX. Finally, it produces carboxylic acid. It is the example for the reaction to the preparation of carboxylic acid. Alkyl halide react with magnesium in dry ether to produce Grignard reagent, and Grignard reagent react with carbon dioxide followed by hydrolysis to produce carboxylic acid.